Okay, so for today's seminar, right? Okay, if you have the notes already, then that's very good. But if you don't have the notes, you can get the notes from our website. Later on, the answers also you can get it from our website lah. Okay, so basically you just have to go to the website. Yeah, basically how you came in lah. Okay, you just get the notes and the answers from here lah later on. Okay, now today's seminar, right, we will have four parts, basically. Okay, yeah, once we're done with the four parts, then very easy, then we are done already. Okay, so the first part, right, we will do Form 4 first. Okay, so we will start with light and optics, because this one I think a lot of people they have problem with this, drawing the lens and all that stuff. Okay, so that's our first part, light and optics. And then for the second part, right, we will go into the resolution of forces, resultant forces, that all that lah, which is your Form 5 Chapter 1. Also where a lot of people have problems. Okay, yeah, that second part. And then the third part, we will go into pressure. Yeah, some schools, probably your exam will be until pressure. Okay, Form 5 Chapter 2. And then the last part, we will do back Form 4 again. But I believe by the time we only have enough time to either do waves, okay, or gravitation. So later we'll see which one you prefer to do lah. Okay, yeah, so you all can choose which one you want to do later on lah. All right, but we will start off with our light and optics question first. Okay, from for chapter 6. Now everything before page number 9, meaning from page 1 to page 8, these are all short notes. Okay, so before your exam, you just read through all these short notes, then it will help you a lot lah. Okay, but today we will start doing starting from page number 9 onwards, which are the questions. Okay, now page number 9 is this question is a sort of a quite a complete question, so we will just start from here lah. Okay, everybody on page number 9. Now I'm gonna sound a bit different now because I'm sick today, okay, but I'll try my best, okay, right, so we have two different lenses here, okay, and they show you what happens when you shine the light into the lens. Okay, you shine the light into the lens, all right, and then they also show you where is the F is the focal point. Okay, yeah, so you can see how they get the focal point lah, right? Where the light shine, it all gathers in the same place. That is the F, that's a focal point. But for this one, you see, the light will go outwards. The light goes outwards. But if you watch carefully, there are some light rays, right, that actually come back and they all meet up at this place here. That's why they know this is F. Okay, yeah. So what are the different kinds of lenses that they use? You compare the type of lens used. So this one, right, is a converging type lens. Okay, where all the lights go together. We call that a convex lens. Okay, so you can write diagram 5.1 is a convex lens. And for 5.2, we call that a diverging type lens, where all the light will diverge, go away from each other. That is actually a concave lens. Okay, usually what I tell my students is, oh, this is a cave. You can stay inside the cave like that. So this is a concave lens, all right? Okay, so compare how parallel rays of light propagate. Propagate means travel. Yeah, propagate means travel. How do the light travel after passing through the lens? So you can say here, the light, they all converge, okay? And then here, the light all diverge. So you have to say that. 5.1, the parallel rays converge after passing through the lens. Okay, and then for 5.2, the parallel rays diverge Okay, after passing through the lens. We don't need to write all lah. Okay, we save time. Yeah, we are not here to learn how to copy. We're just here to learn how to answer question only. Okay, so if anything is too fast, right, you can let me know, okay? But if you cannot copy anything in time, don't worry, later everything is in the answer lah. Okay, you can just copy the answer. I just need you to ask if you have anything you don't understand only. Okay, yeah, if you cannot copy in time, there's always the answer for you to copy later on. All right? Okay, next, compare the position of the focal point. Where is the F? Okay, where is the F? So you can say for convex lens, right, the F is on the other side compared to the where the light ray coming from, right? The light come from here, the F is on the other side. Okay, and then for this one, the F is on the same side. Okay, yeah, as where the light is coming from. So you say 5.1, oops, 5.1. The focal point is on the other side. Okay, it's on the other side of the, okay, where the light come from, right? We call that incident ray. Okay, where the light come from, we call that incident ray. Okay, and then 5.2, the focal length, the focal point is on the same side. Yeah, same side of the incident ray. Yeah, all right, you write down first. You give me 2 minutes, I have to move. Okay, I'm back. All right, so let's continue. So based on your answer in A1, A2, and A3, state a conclusion regarding type of lens and propagation of light. So you just have to say what? Oh, you just have to say, if it's convex lens, then the parallel rays will converge. That's it. You just combine them together only, right? If it's concave lens, then the parallel rays diverge. That's it. You're just combining the type of lens and the propagation of the light. So if it is a convex lens, parallel rays converge. Yeah. If it is a concave lens, parallel rays diverge. That's it. Okay, very easy, very straightforward answer lah. Okay, and then same thing for the next question. They ask you, what is the conclusion regarding the type of lens and the position of focal point? So again, same thing. If it is a convex lens, then the focal point is on the other side. If it is a concave lens, then the focal point is on the same side. Get it? Yeah, pretty easy, huh? Okay, we don't have to write everything lah, huh? Okay, as long as you know what to write. Yeah, as long as you know what to write. Okay, don't have to write everything down. Okay, now, the next question, here we have a movie showing at GSB cinema. Okay, so there's a projector right? And then there's a light that goes through the projector lens and it comes out and it goes onto a screen, right? You all know how cinemas work, right? Okay, so based on the diagram, which lens is more suitable to be used in the projector? Which lens, right, should we use for a projector lens? So it's basically diagram 5.1 or diagram 5.2. Now you see, the thing about this concave lens, right, is that the image will always be a virtual image. Okay? Yeah, for concave lens, the image will always be virtual. Actually, it will always be virtual, upright, and diminished. Okay? So you will never, virtual image means that it cannot shine onto a screen. It cannot shoot onto a wall. Okay? So your projector must be a convex lens because only this one can produce real image. Of course, this can also produce virtual if you put it too close lah. But this can produce real image. This one totally cannot. Always be virtual, upright, diminished. Okay? So you have to use diagram 5.1. You can say diagram 5.1 or you can say convex lens. It will be this, it will be correct anyway. And the reason is because convex lens can produce real image. Okay? Convex lens can produce real image. Yeah, so the characteristic of the image form, of course, you know, is real. Okay, you know it's real. Now, real always match with inverted one. Okay, yeah, I don't know whether I taught you all this before or not, but we have IR and we have UV, infrared and ultraviolet. Okay, no, it's actually inverted, always match with real, upright, always match with virtual. It's fixed already one. All virtual must be upright, all real must be inverted. So this one is actually inverted one. Okay, your movie screen, right, is always inverted one. But you don't see things upside down, correct or not? It's because when they shine on the projector, they put the projector upside down. Yeah, they put the projector upside down. So then when it comes out, right, then the image becomes upright, lor. Okay, so that's how it works. Okay, and the last one is the size lah. Of course, your projector screen, yeah, your movie screen is very, very big, right? So it will definitely be magnified. Okay, it will definitely be magnified. Okay, next. Aside from the application illustrated in diagram 5.3, meaning aside from a movie projector, the lens mentioned in here is frequently used to assist with reading. So when will we use a convex lens for reading? Anyone? Anyone knows what they're talking about? What is the application? Anyone knows what they're talking about? Yes, correct. It is a magnifying glass. Okay? Yeah, it is a magnifying glass. So magnifying glass also use convex lens. But the thing is, for magnifying glass, you produce a virtual image. Okay, you produce a virtual image. All right. So you see, the question never say, right? Okay. But here, they ask you to draw the image for the magnifying glass. Okay, actually, I think this question is missing some, like they never write down. They actually want you to draw, but it's for magnifying glass, okay. This is for magnifying glass one. So let me show you. When you use a magnifying glass, right, you will always put the magnifying glass very close to the object. Let's say you're trying to read something very small. The magnifying glass is not close to your eyes like that one. It's close to the thing you're trying to read, correct or not? because the object, yeah, my object needs to be close to the lens. This is my object. My eye is here, right? So I must put my magnifying glass close to the object. Okay, yeah, so that must be smaller than the f. So anywhere you draw this smaller than the f is fine. You can draw it anywhere. Draw your arrow anywhere smaller than f. Okay, all right, now let's recap a bit on how to draw lens diagram or how to draw a ray diagram. So remember, there are a few lines that you know for sure where it's gonna go. Okay, so the first line is that anything that goes like that, anything that goes horizontal like that, okay, will always go to F. Remember, anything that's horizontal like that will always go to F. So if there is a light ray that is horizontal like that, it will go to F. Okay? Yeah, this one a bit. Okay. If there's a light ray that's horizontal like that, it will go to F. Okay? Yeah? So always, whether your object is here, you just draw one horizontal and then go to F. If your object is here, you draw horizontal, go to F. If your object is here, you draw horizontal, go to F like that. Okay? Now, the second light ray that we know for sure is that anything passing through this middle point, it doesn't bend. Okay? Any light ray that passes through the middle point, it does not bend. It just goes straight like that. Okay? So now you have to find the intersection point between these two. Where is the intersection point between these two? It's not going to intersect here because it's getting further and further away, right? So what you have to do is you have to draw backwards. But the thing is, light doesn't travel backwards, one. Light cannot move backwards. So if you want to go backwards, you have to use dotted lines. Okay, you have to use dotted lines to go backwards. All right. So that intersection point is your image. Okay, now your image location and my image location might not be the same. Your one might be here or here or here because our object is not at the same place. Our object is not the same height. But never mind, as long as your characteristic and my characteristics are the same, which is what? As long as it is virtual, which means it's behind, it's on the same side as the object, it's upright, pointing up, and it is magnified. Otherwise, how does it become a magnifying glass, right? Okay, so it must be virtual, so you can see inside the lens. You see the image inside the lens. It is upright, and it is magnified. Must be like that. Okay, Ken? All right, anyone has any trouble with this drawing? Anyone has any trouble with the drawing? Can okay, so convex lens drawing is always the same method. Go straight, go to F, and then go through the center. Okay. All right, now is for some calculation. Okay, so calculate what? Number one, the focal length, the power, and the magnification. Okay, so the calculation, right? You use the formula 1 over F is equals to 1 over U plus 1 over V. Okay, this is should be up there one if you look here. Okay, 1 over F equals 1 over U plus 1 over V. But you have to be careful about a few things, which is some of the numbers can be negative. Okay, some of the numbers can be negative. So U cannot be negative. Object, right? Always real. The object always exists one. So it cannot be negative. So we don't have to worry about that. But the V can be negative if it's a virtual image. You see like this one? This V is negative V. Okay, this V is negative, right? But here is real. How do I know it's real? Because it's on the other side. The object is here, the lens is here, the image is on the other side, which is what it's supposed to do. It's supposed to be like that. So this is real, it's positive, so no worry there. Okay, so then we can put 1 over f equals to 1 over, you see, you want to use cm or you want to use meter lah, it's up to you. Okay, yeah, if you use cm, everything also cm. So this is 12 for the object, and this is 36, right? From here to here, from the lens onwards, don't take 48. It's trying to trick you. It's a trick question. So you take from here to here. 48 minus 12 is 36, right? Okay, so can you calculate what is f for me? Can you calculate what is f? That might be 1 over f. What you calculated, right? 0.11, right? It should be 1 over f. Then you have to 1 over that number again. You have to 1 over that number. Then you will find. Is it 9? Is it 9? Nicholas says 9. Yes, okay, right, very good. So 9 centimeters, because everything we use cm, right? So the answer will be cm also. Okay, all right, so this is part 1, focal length. Okay, part 2 is the power. Power is 1 over f. Okay, power is 1 over f. Now, if this f is negative, then you have to put negative, like whatever, -9 here lah. Okay, but this one must be in meters. This one must be in meters. Okay, so 1 over 0.09 meters. Okay, 1 over 0.09 is how much? 1 divided by 0.09. 11.11, yeah. Okay, 11.11. All right, now the unit for power. Okay, same as your glasses. If you wear glasses, your power, right, is also calculated in these units, which is D, diopter. Okay, D for diopter. If you know Chinese, right, usually I tell my students, D for 2. How many 2? Your glasses 300 so it's 300D like that. Okay, but the actual word is diopter lah, okay, diopter. All right, what's the third one? Okay, the third one is the magnification. Now magnification is very easy only. All right, magnification, you can take the image height over the object height. You can do that. Okay, the height of the image over the height of the object. Okay, or you could also take the distance of the image over the distance of the object, because it's the same one. If you are taller by 2 times, right? Okay, your distance will be further by 2 times also. Yeah, if you're taller by 2 times, your distance will be further by 2 times also. It's automatic one, right? So you can just take the distance of this divided by the distance of this, which is 36 divided by 12. So it's 3 times. Okay, the magnification is 3 times. Yeah, can I? Okay, next one. So here we have some eye defects like myopia and hypermetropia, basically short-sighted and long-sightedness. This is short-sighted because you're supposed to focus here, but you focus too short now. This is long-sightedness. You're supposed to focus here, but you focus too long already. Okay, so you need some lens in order to fix this problem. Okay, so how to fix this problem? Okay, let's see. Right now, what is happening here? The lens of your eyes is focusing the light too hard already. Do you understand? It's focusing it too much. That's why you see it bends so much. It's supposed to focus lesser, okay? But it bend it so much. So your lens bend it too much. What you need to do is you need to push the light further out first. Okay? Yeah, because your eye lens bend it too much. So you have to push the light further out. So how can you push the light further away? Yeah, I will need a concave lens. Because the concave lens will push the light further outwards, like that, right? So I need a concave lens. So what happens is, when the light reaches here, right, it will get pushed out. You have to draw this, you have to draw this, it will get pushed outwards first, okay? And then only it gets focused back in. Then it will land exactly on the retina. Okay? You have to draw, you have to draw the lens and also the new light rays. Okay? Now, what about for long-sightedness? Long-sightedness is that your lens, right, cannot focus the light enough. It's not focusing it strongly enough. It's focusing it too little already. It's bending too little. So I have to add a lens that is the same shape as my eye lens so that it can help him focus. Correct or not? Yeah, I add a same shape lens so that it can help him to focus in the light first. Okay, help him to focus in the light first, and then only my eyes will focus it. Does that make sense? Yeah, the first one, maybe I should draw a bit more obvious. Uh, okay. Okay, yeah. So you see, it's the same shape one, same shape lens as my eye lens because it helps to focus it more so that it can focus faster. The light can converge faster. Okay, listen, any problems about the short-sighted and the long-sighted? Any problems for this one? Okay, if no, let's continue. Okay, so here, they ask you to calculate the focal length. You know how to calculate it, Okay, we just use back the formula, which is 1 over f equals to 1 over u plus 1 over v. Okay, and then your u, by the way, is the screen. This is the slide. This is the object. This is the image. Okay, so this is u, this is v. All right, 25, 70. You understand? Okay, and then the power is of course p is equals to 1 over f lah. Okay, p is equals to 1 over f. All right, now this one you can just do it yourself lah. Okay, no problem. Let's look at the third one. The third one, right, they tell you the slide has an area of 5 cm square. This one, the area is 5 cm square. Okay, calculate the area of the image formed on the screen. I want to know how big is the image. Now, before we know how big is the image, we need to know what is the magnification first. Okay, we need to know what's the magnification first. So to find out, we can calculate magnification. I told you just now, right? We can use the image distance over the object distance, right? Okay, which is 70 divided by 25. The image distance is 70 divided by 25. Okay, how much is it? 70 divided by 25. 2.8? Is it 2.8? Yeah, if you get a different answer, you let me know. 2.8 magnification. Okay, so you see, this slide, right? Okay, I want you to imagine it like that. Let's say the slide is 2 times 3. Okay, now 2 times 3, right? What is the area? The area is 6 ma, correct or not? 6 cm square ma. If let's say I times 2.8, 6 cm times 2.8 is how much? Okay, never mind. I just want to make it simple. So let's say I times 3. Let's say the magnification is 3. Okay, let's say the magnification is 3. 3 times bigger. Then it'll be 18 ma. But actually, the big screen is not 18, you know. Because what happened? Because actually, here, it'll magnify by 3 times, which will be 6. And here, it'll also magnify by 3 times, which will be 9. So now it's 6 times 9, which is 54 instead of 18. Do you understand? Your magnification apply on both sides one. So you cannot just magnify once only, you know. You have to magnify on both sides, which means you have to magnify 2 times 3 square. Anyone don't understand this or not? You have to magnify by 3 square. 3 for here, 3 for here. Okay, so if you imagine this 6, you times 3 and then you times 3 again, then you're gonna get 54. Okay. So right, the proper way to do this okay, the image size, right, is supposed to be 5 cm square times 2.8 times 2.8. Okay, or times 2.8 square lah. So what is 5 times 2.8 square? 5 times 2.8 times 2.8. 39.2 yeah, you get 39.2 cm square. Okay, everyone got this? 39.2 cm square, okay. Now, for the essay question, I'm not going to do the essay question for today, okay? But I need you to go and read up on the essay question, okay? Later on, before your exam, you go and read the answers for all your essay question. Because essay, you know how to do already. It's just that whether you have the common sense or not. Okay, I always say you must be able to get that common sense. You must be able to know, oh, this should be what, this should be what, this should be what, like that. Okay, all right, now we're going to go into part 2 of our seminar, which is our Form 5 Chapter 1. Okay, so you go to page number 17. Page number 17, we will start to go into Form 5 Chapter 1. Okay, now remember, for this chapter, I just need you to remember a very, very important thing, which is any Saget force can be split into horizontal and vertical. Okay, any Saget force can be split into horizontal and vertical. Okay, yeah, this is a very, very important thing to remember. All right, so Here we have a billboard hung by two identical cables. All the forces are in equilibrium. Each cable can withstand a force of 1,100 newtons. What is the meaning of forces in equilibrium? Now, when we have equilibrium, that means everything is balanced. But we don't say like that now. We don't say everything is balanced. Everything balanced means up equals to down, left equals to right. Okay, so how do we say everything is balanced in proper physics words? We say the resultant force. Resultant force means all the forces add up together. Okay, up minus down, left minus right. The resultant force is zero. Okay, resultant force is zero. Yeah, so we say that. Okay, or you can say there is no resultant force acting on the object. Okay, next. In the diagram, mark and label the weight of the billboard, the tension of the cable T1 and T2, and their directions. Okay, so first of all, right, the weight will always be pointing where? Weight will always be pointing down. Okay, weight will always be pointing down towards the floor because of gravity, ma. Okay, then tension is inside the string here. One tension here. Okay, this is T1, let's say, and then another tension here. This is T2. Okay, now what about the direction of the tension? If the weight is pulling it down, then the rope must be pulling it up, ma, correct or not? The cable must be pulling it up, ma. So that's why it's pointing this way. Okay, this way. Okay, T1, T2, W. Now, calculate the weight of the billboard. Okay, calculate the weight of the billboard. Now, weight is very easy only. You should know the formula already. W is equals to mg. All right, the mass is 150 kilograms. And the G is, of course, 9.81. Okay, this is given the mass. So 150 times 9.81 is how much? Should be 1,400 something lah. Right? Or 1,300 something. One for what? Hmm? 150 times 9.81. You press divide, is it? I think you press divide. 150 times 9.81. 1471.5. Okay, yeah, 1471.5 newtons, because weight is actually a force. Okay, don't forget, weight is actually a force. That's why we can do all these calculations, because we know weight is a force, and we know the forces, they must balance each other up. Okay, yeah, that's why we can do questions like this. Okay, so now sketch a triangle of forces that act on the billboard if the angle is 40 degrees. Okay, now when something is in equilibrium, okay, only when it's equilibrium, your triangle will be a perfect cycle, meaning the arrows will all match up with each other one. Only if it's equilibrium. If it is not equilibrium, your arrows will not match each other into a perfect triangle. Okay? But if it's equilibrium, they will match each other into a perfect triangle. Okay, so now what you have to do is this. You look at these three things, right? Okay, you take your ruler. Okay, you just match it. Let's say I draw W first. Okay, W. I bring down. I draw one line. This is W. Okay, yeah, this is W. All right, then I have T. Now they say T, the angle of T1, T2 is 40 degrees, right? Okay, so actually I should be drawing 40 degrees like that lah. Even though I'm supposed to match T like that, right? But because they never draw properly, so I will put 40 degrees. I'll use my protractor, measure 40 degrees. This is T1, okay, so I just move it down here, and I just draw T1 like that. Okay, now for the other side, okay, again, his one is not 40 degrees, okay, but I will draw it at 40 degrees lah. Okay, yeah, but I want to match the direction only. I just want to match the direction for T2. So I just put it down here, make a triangle, okay, and then draw. That's T2. Okay, that's how you always draw triangle. You always match with the picture and then you draw. You match with the picture and then you draw. Okay, of course, any extra you can just erase away. All right, any extra you can just erase it away. Then you have a perfect triangle already. All right, yeah, where this part is 40. Okay, same as the T1 there, down there is 40. Okay, and then this part is 40. Like that. Okay, now if you don't want to label the 40, right, you can always label the inside angle one. Okay, meaning I don't want to label this 40, right? I label this is 50. Yeah, because I know what? This is 90 degree what? Yeah, 90 degrees ma. So if this is 40, then of course this is 50 ma. Okay, yeah, and then this one, right? This one is also 50 because this one is 40 here. This one 40, same as this one. So this is also 50. And then this is 80 because total must be 180. Okay, yeah. There's a second option for your triangle, which is this way, but it is exactly the same answer. It doesn't really matter. In case some of you drew this triangle and you're wondering whether it's correct or not, it's correct. Okay, it's not wrong, it's correct. Same triangle. Okay, so next, a few seconds after the billboard is hung, it is found that the cable of the billboard snapped. Calculate the tension in the string, meaning calculate what is T. Okay, calculate what is T. Yeah, explain why the cable snapped. So, see, how to calculate T, right? Very easy. I just want to look at one of the T. Don't look at both together. Because look at both together, you got two unknowns, right? So might as well I just look at one only. Okay? So if I just look at one of the T, yeah, just choose any one of the T. So I'm gonna look at this triangle, let's say. Both T's are gonna be the same, so you don't have to look at both, okay? I'm just gonna look at this triangle here. Can I? Okay, what is this? This is T2. And what is this? This is W, but divided by 2. Do you know why is it divided by 2? Because the other half is here. This whole thing is W, but I only want half of it. Which makes sense because the two cables, each person will take half the weight, right? The two cables share one, so the two cables, each person will take half of the weight. Okay, yeah. So then we can say, let's say, where's our angle? Or this is our angle, 40 degrees just now. Okay, we can say, let's do saw. All right, sine 40, sine angle is opposite over hypotenuse. The opposite is what? The opposite is weight divided by 2. The weight is 1471.5. So we have 1471.5 divided by 2. That's the opposite. Over the hypotenuse is the T2. Just T lah, can also, just T also. This because both T's are the same. Okay, both T are the same. So you do T equals to 1471.5 divided by 2 divided by sine 40. Okay, so you check how much you get. You do the top first, and then only you divide by sine 40. 472.93 only, meh? So little ah? Shouldn't be, right? Yeah. Because this one is 0 point something, should be. You check whether your calculator is in radian or not. Change to degree mode, remember? One 44.62. Do you get that? 1144.62. Yes, okay. Same, 1144.62 newtons. Okay. Now, this is more than 1100 Newton. Okay, because they say that the cable can only withstand the maximum force of 1100 newtons. That's why it snapped. Okay, yeah, that's why it snapped. You just tell him lah, because the force is greater than the maximum force of 1100 newtons that the cable can withstand. Okay, understand? All right. So the billboard is broken when it drops from a height of 10 meters. By ignoring air resistance, calculate the time taken for the billboard to reach the floor. Okay, this is actually a SUVAT question. I don't know whether you can tell well lah. Okay, but when you have a height, when you have a time, when you have a falling, usually it's a SUVAT question. So in case you've forgotten, you write down what is the SUVAT first, S with VAT. Okay, S is the distance you have to travel, which is 10 meters. U is your starting velocity before you fall. Before you fall, your starting velocity is 0. Okay, 0. Now, after you fall, the final velocity, this final velocity is not when you hit the ground. This is right before you hit the ground. We don't know. We don't know what is the speed right before it touches the ground. The A we know. The A, right, is actually your gravity. Because you fall down due to gravity, so your A is actually 9.81. Yeah, the acceleration due to gravity. Okay, and then your T is the time taken, which is what we're trying to find. So you have SUA, and you're trying to find T, okay? The SUVAT formula you have to use is S equals to UT plus half AT squared. This time your exam, your teacher say got give you formula sheet or not? Because normally Form 4 first time exam, they don't have one. Form 4 first time exam, no formula sheet one. But I don't know Form 5 they will give or not. Usually Form 5 they will give like same like something you get during SPM. Your teacher say whether you all will get formula sheet for your exam or no? Never say. Probably will. Okay lah, hopefully got lah. Okay, so S is 10, U is 0, T, 0 times T is 0, half 9.81 T squared. Okay, so this one will be 0. You don't have to write this thing. Okay, so 10 is equals to 4.905 T squared. You find what is T squared, then you can find T square root. T squared is 10 divided by this. Not this divided by 10, 10 divided by this. T 1.43. Okay, see whether you'll get the same answer or not. T is 1.43 seconds. Okay, 1.43 seconds. Yeah, right. The next one is the impulsive force. Impulsive force, right, is the force when it boom, when it hits. Okay, yeah, the force when it hits something. Okay, so when you calculate impulsive force, the formula is this: F equals to mv minus mu over t. This one actually comes from F equals ma. Okay, yeah, F equals to mv minus mu over t. Now, the mass, right? The mass is 150 kg. Okay, same billboard, it's the same question. The problem is the V and the U. You see, this V is not the same as this V. This U is not the same as this U. Because what? This one, right, is the falling portion. This is the crash portion. So we have two parts. We have the ew, then we have the bam. Okay? This is the kaboom part. This is the ew part. You understand? So, right, let me ask you, the kaboom, right? Once it hit the ground, it goes boom. The final velocity is 0. Yeah, the final velocity is 0. Because once you hit the ground, you already stop. But the initial velocity, you have to get from where? You have to get from this. You know why? Because the right before it hit the ground, right? That's your final velocity, correct not? This is the first moment of your crash. This is right before you crash. Do you agree? Right before you crash. So that's the initial velocity of the crash. So you got to find out what's the V here. Yeah, find out what's the V here. So you can do V equals to U plus AT. Okay, U is 0, A is 9.81, T is 1.43. Okay, so what is your final velocity when you fall down? Final velocity when you fall down? (14.02). No. Yeah, correct. The initial, right? Initial velocity is right before you crash, correct? So what is the velocity right before you crash? Is the final velocity of your falling. Yeah? You see, you start from here, right? You fall down. This is your initial velocity of the falling. This is your final velocity of the falling, agree? But what about your crashing? Your kaboom. This is your initial velocity of the crash. This is the final velocity. The final velocity of your crash is stopped already. Final velocity of your crash is 0. But the initial velocity right before you crash is the final velocity of your falling. Do you agree? Makes sense, right? Okay. So what is this final velocity of the falling? 14.02 ah. Yeah, 14.02 ah. So big ah. 9, 10, 10. Oh, yeah, correct. 14.02. Okay, so we put it here lah. 14.02 divided by the time. This time is different from this time also. This time is a kaboom time. The kaboom time is this. Kaboom time is a time of impact. The crashing time is 0.5 seconds. Okay, yeah. So calculate this for me. Negative 4206. Okay, the negative doesn't matter one. The negative force can be negative one. It's about direction only. Yeah, force is about direction only. Okay, can. All right, so why the billboard is broken is because the impulsive force is very large. Okay, yeah, very large impulsive force. But you must explain to them why is the impulsive force large? Is because number one, this time is short. When you have a very short impact time, the force is very painful. That's why when you fall on the mattress, it's not painful. Because when you fall on the mattress, it's not bam like that. It's boing like that. Very long time. So the force becomes very small. Okay? That's one thing. The other thing is the velocity is very high. You fall very quickly. Yeah, you fall very quickly. The velocity is very high. So then it's also painful also. Okay? So you say the hard surface of the ground causes a short impact time. Okay, yeah. The billboard also falls with high velocity. Okay. This results in a high impulsive force. Okay, this results in a high impulsive force. Large mass, yes, correct. Large mass is also one of the reasons. Yes, you can mention also the mass of the billboard is very high. Okay, so the mass also affects the impulsive force. You are correct. Okay, can Okay, so this one also is an essay question. Later you can just read through the answer lah. Okay, but in general, let me just tell you, the bigger the angle, the lesser the tension. Okay, you just check back from here. You check back in this part, right? You try using sine 60 instead of sine 40. You realize that your tension will be smaller. So remember, whenever we have a hanging problem, like you're hanging things with two ropes, doesn't matter whether you hang this way or whether you hang this way, okay? The bigger the angle, the lesser the tension. It's always true one. You just have to try using this formula here, this equation. Change the angle to 60, you'll see. Okay, Ken? All right, now we're gonna take a short break, just maybe 3 minutes only. Yeah, so 3 minutes, we will come back at 11:11. Okay, and then we'll just continue. Just a short toilet break only. All right, yeah, we'll be back in 3 minutes. Okay. Okay, let's continue. Let's continue. Okay, now we move on to part 3 of today's seminar, okay, which is about pressure. Okay, Form 5, Chapter 2, pressure. Now, for pressure, right? For this chapter, we have Archimedes. Uh, so mostly we will focus on Archimedes only, right? So let's have a look. Now, this is a Cartesian diver. Now, Cartesian diver is mostly what do you call this? A toy lah. Yeah, it's basically mostly a toy lah. Okay. And why you come here, Wilson Lim? Okay, so we have some holes in the Cartesian diver, and it allows water to flow in and out of the Cartesian diver. Okay, now when you squeeze the Cartesian diver, right, the Cartesian diver will actually fall down. Yeah, okay. When you let go, it'll automatically float up again, one. So that's why I say it's mostly just a toy, lah. Okay, but the concept is based on Archimedes' principle. Okay, so name the force F acting upwards on the Cartesian on the Cartesian diver. Okay, so the upwards force, right, to make the thing float, of course, we all know is called buoyant force. Yeah, so we call it buoyant force. Okay, buoyant force, and state the relationship between the force and weight. Okay, right now, when the Cartesian diver is floating, floating means that it is not moving up, it is not moving down, which means what? Which means that these two must be the same. Okay, the up and down must be the same. So we say buoyant force, buoyant force equals to weight. Okay, buoyant force is equals to weight. Yeah. Okay, next. The Cartesian diver sinks when the bottle is squeezed, as shown in diagram 7.2. Explain why the Cartesian diver sinks. Okay, so you see, right now, inside the Cartesian diver, right, don't have anything one. Okay, it's air lah. It's air basically. Right now inside is air. That's why it can float ma. When you squeeze, right, you will increase the water pressure. Right now, okay? You increase the water pressure. So the water is basically forced to go inside. Yeah? The water pressure increase, so the water will go into the Cartesian diver. Okay? So when the water goes in, then it's like a submarine anymore. You let the water come in, your weight will become bigger than your buoyant force. Okay? So then you will sink. So we will say, okay, when bottle is squeezed, okay, pressure on the bottle forces water to flow into the Cartesian diver. I keep saying driver now. Cartesian diver. Okay, so the weight of the Cartesian diver increases. Okay, right? When the weight is greater than buoyant force, okay, when weight is greater than buoyant force, the Cartesian diver sinks downwards. Okay, when the weight is greater than buoyant force, because the buoyant force never change, right? Yeah, remember buoyant force depends on what? Buoyant force depends on the volume of water that you push away. Okay, if you push away this much volume, yeah, this amount of volume, your size never change, ma. You are still the same size, ma. So you are pushing away the same amount of water. Your buoyant force will always be the same. You can only change your buoyant force if you change your volume. You become bigger or you become smaller. So the buoyant force cannot change, but your weight increase when you add water inside. Okay, so like I said just now, this is same as what? This is same as a submarine, correct or not? So the submarine, the part where the water goes in, what is that called? Do you remember or not? The part where the water goes in. Do you remember what is that called? What tank is that? Very good. Yeah, it's called a ballast tank. Okay, so it's a submarine ballast tank work exactly the same way. Okay, the submarine ballast tank work exactly the same way. Okay, yeah. All right, now again, I'm gonna skip this essay question. Okay, right? I want to do a calculation question for this Archimedes. Okay, so this here is a hydrometer. Hydrometer basically is for you to measure the density of the liquid. How dense is the liquid? Okay, so you just have a tube and then you have some weight inside so that the tube can float upright. That's a hydrometer already. Okay, so this is using Archimedes principle, of course. We are still talking about buoyant force, Archimedes principle. Okay, and we also know that buoyant force must be equals to the weight lah. Okay, because it is just floating there only. It's not going up, it's not going down, it's just floating there. Okay, now calculate the buoyant force when the mass of the test tube and sand is 0.05 kg. Okay, so here, right, many people when they see calculate the buoyant force, they will automatically go and think, oh, buoyant force is equals to V rho G or rho Vg. Okay, but you don't jump there first. Okay, because what they gave you is the mass. Okay, so the mass, right, is actually related to this, to the weight. So instead of this, you should be using buoyant force equals to weight, which is equals to mg, right? So the mass is 0.05, g is 9.81, then you can get the buoyant force already. Okay, without thinking, oh, what is the volume? What is the density? Like that. Okay, so how much is this? 0.05 times 9.81? 0.49, okay, newtons, right? Because buoyant force and weight, they are both forces. So it is newtons, okay, newtons. All right, the same test tube is then immersed in a beaker of petrol. Predict the length of the test tube that is submerged. Explain your answer. Okay, so to answer this question, right, first, I need you to think back. Does petrol float on water or does petrol sink underwater? You have to think about that first. Does petrol float on water or not? Petrol float on water, right? That's why we have all this sea pollution. The sea pollution happens, a lot of it is because the oil tanker they have accident on the sea. Then all the oil float out, all the oil come out, and then it just floats on the ocean only. Then it pollutes the sea. It blocks the sunlight, and then all the animals they get covered in the petrol. Okay, so remember, petrol floats on water. So what does that tell us? That tells us that petrol is less dense than water. Okay, so we start from there. Petrol, whoever is less dense will float. Okay, petrol is less dense than water. Okay, now see, if you go into something dense, you will become less dense. You will float. Okay, but if you go into something that is less dense, that means you are now quite dense, right? So you will sink down even more. Do you understand? Okay. If whatever is around you is less dense, that means you have become denser. So you will sink down even more. Okay. So why is that? Because, right, rho Vg, V rho G, if this rho is lesser, you need more V to balance it out. Okay? You want to produce the same buoyant force, you need more volume inside water. So you have to sink down a bit more. Does that make sense? Yeah, you have to sink down a bit more in order to produce the same buoyant force. Because your density dropped down already. Someone must come in and fill up. Yeah. Okay, so you say, in order to produce produce the same buoyant force. Okay, in order to produce the same buoyant force, the test tube must submerge more. Okay, in order to produce the same buoyant force, the test tube must submerge more. Okay, understand? Yeah. Okay, so now let's look at this question here. So this sampan, this boat will sink if the water level exceeds line WR. Okay, yeah, it will sink if the water levels exceed this line, meaning if it's go above like that. Okay, the mass and the average surface area of the sampan is 100 kg and 2 meters square. Okay, so calculate the maximum mass of passenger that can be ferried without exceeding line WR. Okay, so basically, right, I want to know how much weight I can have. Okay, so that it doesn't what do you call this? Sink lah. Okay. Because if I want to find how much mass, I cannot find yet. I need to find how much weight first. Right now, we're dealing with forces first. So let's say, right, the water is ngam until here. Okay. Let's say the water is ngam until here. What is the buoyant force here? Okay. So you see, immersed height. Immersed height is how much? 0.5 minus 0.12, correct? Okay, which is 0.38 lah. Okay, so what is the immersed volume? What is the immersed volume? Right now it's ngam on the line. Okay, so how much volume of the boat is inside? They give you the area of the boat. So area times height, you get the volume lah. Do you understand? Yeah, volume is always area times height. So we can take 2 times 0.38. Okay, 2 times 0.38. So that's 0.76 meter cube. Okay, just until here only. Anyone don't understand what I'm doing? Just until here. Anyone don't understand what I'm doing now? Okay, can I? All right. Okay, next one. I want to know what is the buoyant force now? What is the buoyant force when the boat is this submerged inside? So I can use V rho G. Right now, where V is the submerged volume, rho is the density, and G is 9.81. Okay, so I just substitute all my answers. 0.76. Density is 1000. G is 9.81. So can you calculate what is the buoyant force? Seven four five 7,455.6. Okay, right? 7,455.6 newtons. Now, would you agree that for it to be balanced, the weight of people plus the weight of the boat must be equals to the buoyant force, correct or not? Yeah, in order for it to be balanced, right? The weight of people and the weight of the boat must be equals to the buoyant force. Cannot be more lah. At most must be equals only. That's the maximum. So I can say buoyant force is equals to weight of people plus weight of boat. Okay, so 7,455.6 is equals to the weight of people will be the M times the G, okay, plus the weight of the boat is also the M times the G, but I already know the M. The mass of the boat is 100 kg. Okay, you all know what am I doing? This is mg of this is mg of this. So then you can find out what is the mass of the people lah. Right? What is the maximum mass of passenger? 660. Okay, check whether you get 660 or not. Yep, for mass is kilograms. 660 kilograms. Yeah. Okay, right. So that is for the pressure chapter 2 question lah. Okay. So now we go on to the last part of our seminar for today. The last part will be again from 4 topic. So I think we have time. We should have time to do both interference of wave and the satellite question. Okay, we'll try to do both lah. Okay, so we start from the interference question first. This is on page number 28. Yeah, page number 28. Okay, so the first one, right? The frequency of sound wave produced by the loudspeaker is 1000 hertz. So basically, I have a two loudspeaker here playing the same sound. When someone walks this way, he will hear alternating loud and soft, meaning loud, soft, loud, soft, loud, soft lah. Okay, so what is the meaning of wavelength? So wavelength, right, is basically the length of a wave lah. Okay, but you can tell them how do you get the length of the wave. So you can say the distance from one crest to another crest, meaning here to here, all right? Or one throw to another throw. Okay, so you can say distance from one crest to the next crest. Or you can use throw. Okay, throw means the bottom. Yeah. All right. So based on the diagram, calculate the distance between two consecutive loud sound. Okay, two consecutive loud sound means what? Meaning here to here lah. Let's say A and C is loud sound lah. Or here to here. Okay. Or if let's say B and D are loud sound, A and C is soft, then that's a distance lah. But of course, from this, it's very hard for you to calculate B and D, right? Because you have 5 meters from here to here, ma. Okay, so better to do this. Loud to loud, loud to loud. Okay, so this is 1, 2. Now, two distances is 5 meters. You don't count 1, 2, 3 loud sound is 5 meter. So then you take 5 meter divided by 3. No, it's two distances is 5 meters. So one distance is gonna be 5 meters divided by 2. Okay, 2.5 meters. You understand? Oh, I just realized this is another. I just realized that this is actually the second interference question already. Okay, never mind lah, since we're already doing this. Okay, all right. Calculate the wavelength. So the wavelength, we can use the formula. Interference will always have this formula, lambda equals to AX over D. All right. I already showed you what is X already. The distance between two loud sounds or the distance between two soft sounds. This is the A. Distance between two sources. Yeah, the distance between the two sources. And then this is the D. Distance from the source to where you are looking. Okay? Distance from the source to where you are measuring. So now you know what is everything. You can put all the numbers in. A is 1.5. X is 2.5. And D is 3.0. Okay? And you can calculate what is this wavelength. This divided by this 0.5. So it should be 1.25 lah. Okay, if I'm not wrong. 1.25. And it's meters, meters. First is a length, right? It's a length. Okay, now, always after you do this calculation, right? Always, almost 99% of the time, I can guarantee, they will ask you, what happens if you do this? What happens to one of the things if you do something? So like they say, what happened to the distance between the loud sound? What happened to the X? Right? What happened to the X when the pitch of the sound is increased? Okay, what happens to the X when the pitch of the sound is increased? Okay, so first you need to know, if the pitch of the sound increase, how does that affect anything here? So it doesn't affect A because A is the distance between the speakers. You change the sound, you don't change the distance of the speaker. It also doesn't affect D. You change the sound, you don't change this thing also. You're just changing what you play only, ma. All right. So what it does is it affects the wavelength. But how does it affect? You see, pitch, right, means what? Pitch means frequency. Okay, remember, pitch means frequency of the sound. So you say, when pitch increases, okay, when pitch increases, frequency increases. Okay, when pitch increases, frequency increases. Now, don't know whether you know this or not, but frequency and wavelength, right, are reversed with each other one. Because this is high frequency. You can see the wavelength is short. This is low frequency. You can see the wavelength is very long. Okay? So frequency and wavelength are, they are opposite to each other one. So if the frequency increases, wavelength decreases. Okay? If the frequency increases, wavelength decreases. All right? Okay, now, when this thing decreases, what happens to the X? So you just have a look. Both of them are on the same level. Same level as in both of them are on top. There's actually a 1 at the bottom one. You just cannot see only. Right? There's actually a 1. So both of them are on top. Like this and this, these two are different level. He is on top, he's at the bottom. Can you see that? Yeah, these two are different level. So these two are the same level on both sides. One is on the left, one is on the right, right? That means they will both go up together and they will both go down together. Okay? Yeah, they'll both go up and go down together. So when wavelength decreases, the distance between loud sound decreases. Okay. When wavelength decreases, the distance between loud sound decreases. Loud sound is anti-note, correct? Loud sound is constructive interference, which is anti-note. The point where you have the loud sound, we call that the anti-note. Soft sound is called note, which is where we have destructive interference, where the sound cancel each other out. Yeah. Okay. Now I'm gonna skip the essay question again, and we'll look at the final question, yeah, which is this satellite question. Okay, so just in case we have some Form 4, Chapter 3 questions. Okay, so we have Miasat 3D, which is a satellite orbiting around the Earth, and we also have a moon orbiting around the Earth. Okay, What is the meaning of centripetal force? Centripetal force, right, is a force that always go towards the center. Yeah, this thing go around, right? There is something always pulling in one. Okay, there's something always pulling in towards the center. Otherwise, this thing fly out already, no? Yeah, as it spins, fly already. The moon also, there must be something pulling the moon in. Otherwise, the moon already fly away already. Okay, so you say centripetal force is a force that is always acting towards the center of a circular path. Only happens when you move in a circle. If you don't move in a circle, usually there's no centripetal force. Okay, always happen when you're moving towards a circle. Or when you're moving in a curve, the curve is also part of a circle, actually. Okay. All right. Next, calculate the height of the Miasat from the surface of Earth. Okay, they want to know what is the height. Now, the height, right, is this part only. This is the height. Okay. Every time we do any calculation for this chapter 3, right? We use something called R, small letter R. Now, this small letter R is from the center to the center, meaning from the satellite to the center of Earth. Okay? From the satellite to the center of Earth only. So that is your small letter R. So later, whatever small letter R we calculate, we are getting this thing. You must minus the radius of Earth. Then only you get the H. Okay? Yeah, just to inform you. All right, so now we have to find R first. How do we find R? Okay, so we have to refer back to our formulas. Okay, so let's say what formula do we have? Now, we have this thing, which is the velocity, but we don't have the velocity, so we cannot use this. Okay, we cannot use this. Now, we also have this formula, which is Kepler's third law, but we also cannot use this. Yeah, we also cannot use this because we don't know the period. We don't know how long it takes to go around. Okay, yeah, so we cannot use that also. So, oh, they never give others already. Okay, so if they never give others, right? Usually in your formula sheet, you have other formulas also. Okay, your formula sheet, you have other formulas also. Hey, where is the question now? Okay, so usually there will be one formula, which is this. Let's say t squared equals to 4 pi square r cubed over gm. Sometimes they give this formula. I mean, usually they'll give this formula. Okay, t squared equals 4 pi square r cubed over gm. Now, you need to know what all of the things mean. T square is the period. Okay, now we don't know the period of the moon. That's why we couldn't use t square over r cubed equals t square over r cubed. But we know the period of the satellite. How then? Because it is a geostationary satellite. Geostationary satellite means it will always go one round in one day, same as Earth. Okay, so that's geostationary satellite. We know the period of the satellite. Okay, R is what we're trying to find out. Yeah, you know 4, you know pi. G is given here. This M, capital letter M, is the mass of the whatever is in the middle. So in this case, it's the mass of Earth, which is given to you already. Okay, so you can use this formula to find, right? You can use this formula to find. So t square is gonna be the what do you call this? Period of the satellite, which is one day. Now you got to change to seconds because that is the standard units. You have to change it to seconds. So it's 1 day, there's 24 hours, okay? 24 hours, there's 60 minutes, there's 60 seconds. If you multiply this, right, you should get 86400. If I remember correctly, lah. In 1 day, there's 86400 seconds. Yeah, if you do this correctly. If it's not, you let me know. Okay, square this. You have 4 pi square. You're trying to find the r cube. G is 6.67 times 10 power negative 11. Always given, always given. Mass of Earth, 5.98 times 10 to the power 24. Okay. Yeah. So you take this, multiply this together, bring over there to multiply, and then divide the 4 pi square. Divide the 4 pi square and you get r cube. After you get r cube, you just cube root it, then you can get the r. So let's start from there first. Let's get the r first. Let's get the r. That's r, Nicholas. Is it? 4.23 times 10 to the power 7. Okay, y'all check whether you get the same number. 4.23 times 10 to the power 7. Okay, see whether you'll get the same. And remember, r is only this distance, this whole thing. R is this. You want the height only, you have to minus off the radius. Yeah, you have to minus off the radius. So the h will be this minus of radius. Okay, the h will be minus of the radius. Okay. Should be left with 3 point something something times 10 to the power 7, right? After you minus. Correct. You get 3 point something something times 10 to the power 7, 3.59. Anyone couldn't get these numbers? Anyone cannot get these numbers here? Can okay. All right, now the radius of the orbit is this amount. Calculate the orbital period. So now we can use the formula just now, which is t squared over r cubed equals to t squared over r cubed. Okay, so we already know the t of the satellite. We know the r of the satellite. We just calculated it. We know the t, or we don't know the t of the moon, but we know the r of the moon. Now, this t, right, you don't have to change the seconds here. Because for this formula, As long as both sides use the same units, you'll be fine. So you can use days instead of seconds, which is much easier. Because for Earth, right? I mean for the satellite, right? It will be 1. Yeah, 1 square over the R 4.23 times 10 to the power of 7 cube. Okay. For the moon, 3.844 times 10 to the power of 8. Now, be careful, many people forget to cube this thing, okay? And then you get t squared, which will let you get t. Okay, so the 1 is just 1 lah. 1 square is just 1. You just bring this over, it becomes multiply. Okay, so you take this thing, you bring up here, so this thing divided by this thing. Okay, yeah, this thing divided by this thing. But remember the cube first lah. Remember the cube first. Then you get t squared, then you square it, you get t. Don't come here kacau lah, you from 4, go back from 4 lah. Okay, can get the t or not? I mean, by general knowledge, the t should be 27, 28 one. It's supposed to be days, ma? Because I use 1 day here, ma. You got square root or not? The answer is it t squared or not? Do you square it or not? I just use 1 day, so the answer should be day also. Your 657, is it haven't square root yet? By general knowledge lah. Moon supposed to orbit around 27, 28 days one. I mean, technically lah. Unless the numbers are wrong lah. Oh yeah, you use then you divide by 24 hours long. There's 27 days, is it? Okay lah, okay. So you should get like 27, maybe 27 point something days lah. Okay, but it should be around there one. Okay, that's the correct the correct time lah, correct period for our actual moon. Okay, now last question, why the Miasat can orbit around the Earth? Okay, so remember, the reason why things can go around in a circle is because the thing actually want to do what? The thing actually want to go straight. But there is a force pulling in. As a result, you will go here. Okay? Yeah, when the two forces combine together. Then when you're here, you want to go this way. But there's a force pulling you in. So as a result, you go here. Do you understand? It's always like that one. Okay, so you say when the Miasat is launched, the inertia causes it to move forward. Okay, with constant speed. So that's the first part lah. It's supposed to move forward one. It's not supposed to go in a circle one. It's supposed to just go straight only. Okay? But there is a gravitational force. That's your centripetal force lah, by the way. There is a gravitational force or centripetal force from Earth. Okay? There is a gravitational force or centripetal force from Earth acting on your side. Okay? Yeah? So this force is perpendicular, meaning 90 degrees. This force is perpendicular to the motion of Miyasat. Meaning wherever you go, my pulling force is always 90 degrees to you. You go here, I pull 90 degrees. You go here, I pull 90 degrees. You go here, I pull 90 degrees. Okay? So the force is perpendicular to the motion of Miyasat. So the resultant force, okay, causes Miyasat to orbit in circular motion. Okay, the resultant force causes the Miyasat to orbit in circular motion. Okay, understand? Yeah. All right. So basically that's all for today. We have covered a lot of things already. Actually, we've covered chapter Form 5, chapter 1, chapter 2. We have also covered a few chapters from from Form 4 also. Okay. So sorry about the sound because I'm a bit sick actually quite sick so if there's anything you miss out, right, anything you didn't copy in time, again, the answers are already in the on the website. Just go to the website and click for the answers lah. And make sure, please make sure you read the essay answers. Okay, you have to read through the essay answers so you know which one to choose. All right. Okay, so any questions? Yeah, if no questions, then that will be all for today. And I will see you guys again in our normal class lah. Okay. All right. Bye-bye. Okay, thank you. Bye-bye.